Hello, geometry student, and welcome to Inscribed Angles. In this lesson, you'll be provided with problems where you will have to use an inscribed angle of a circle to help you solve problems. Now, here's what an inscribed angle looks like. An inscribed angle has its vertex on the circle. So see right here is the vertex of this angle, okay, this inscribed angle. So this represents, like I said, this represents an inscribed angle. And so an inscribed angle will always face an arc. Okay, so here's the vertex, here's the angle right here. And then an inscribed angle will always face an arc. And so this arc is right here. So this is like arc AB. And so to find the measurement of each of these, you just use this formula. If you're given the angle, okay, or if you're looking for the angle, I should say, then all you have to do is take the arc measurement and do half of it, okay, and that gives you the angle. So that's where this part comes in. If you are given the angle and you're looking for the arc, then you have to double it, okay. So just real quickly, just to kind of show you what we're doing here, if angle one in this picture was 30 degrees, then that means that the arc, the measurement of arc AB would be 60 degrees, okay? Because the inscribed angle is half of the measurement of the arc that it's facing, that's intercepting. Likewise, if I told you that the measurement of the arc was 80 degrees, okay, then to find the angle one that it's facing, then you take half of 80, which is going to be 40 degrees, okay? So the angle is half of the arc is double the angle, okay? All right, let's do some problems. All right, so in this first problem, we have actually a two-part example, and notice here that they've given you 40 degrees for this angle here, and then they give you 98 degrees for this arc. So let me give you just a moment to make sure you have that. Make sure you just draw this picture, okay? All right. And so now what we'll do is we'll actually answer the question here. So the question for part A is to find the measurement of arc CF. Well, to find arc CF, of course, is this arc right here. Let me highlight that. This arc here, okay? And notice that this arc is facing this angle. So this is the angle that's facing that. So we have an angle, this inscribed angle is 40 degrees. So since we're given the angle and we're trying to find the arc measurement, then all we have to do is take the arc measurement. To get the arc measurement, we're going to take 2 times the measurement of the angle, which is CDF. So the measurement of angle CDF, that's what that is, okay? And so all we have to do is do the arc CF, measurement of arc CF, is just 2 times 40. And so 2 times 40 is 80 degrees. So therefore, the value of the arc is 80 degrees. Or assume the value, yeah, the value of the arc is 80 degrees. Okay? Because the inscribed angle is 40, so you double it. All right? Now, let's erase this. And actually, what I'll do is I'll actually duplicate this. Let me go ahead and duplicate this page. And that way you can keep everything kind of at the same thing here. All right. So now all I'm going to do is I'm going to erase this part right here. And now I'm going to deal with finding angle C. Okay, so angle C is an inscribed angle because its vertex is on the point on the circle. So here's angle C right here. Okay. And so now let's look at what arc it is facing. And so this arc that is intercepting is right here. So that's 98 degrees. So that's arc DE. So to find the measurement of angle C, what we will do is we will take the measurement of the arc and take half of it. So basically it's just 1/2 of the measurement of arc DE. So the measurement of arc DE. So half of that. So all it is just 1/2 times 98 degrees, because that's what the arc of measurement of arc DE is. So half of 98 is going to be 49. So therefore, the measurement of angle C is 49 degrees. Okay. All right. Let's go to example number 2. So example number 2 is they give you some measurements. So they tell you that angle S is 3x degrees. So here is angle S. So that's this angle here. Okay, so 3x degrees. And then angle V, which is here, so we'll point to this angle here, is going to be 2 or x plus 16 degrees. And so they want you to find the measurement of angle S. Okay, now, once again, what we have here is we have the fact that we have 2 angles given to us. But I need you to see something here. What you may see at this point is that this angle here, so I'm going to highlight angle S. So here's all of angle S. And notice that this angle is facing this arc, which is TU. Okay, so angle S is facing TU. But if you look at angle V, okay, look at angle V. Notice that angle V, if I highlight that angle, it too is facing angle arc TU. It's facing arc TU. So since both angle S and angle V are facing the same arc, okay, they're intercepting the same arc, that means they are congruent to each other, okay? So let me make a note of that, and I'd like for you to make that note as well, okay? If 2 angles, so write that down, if 2 angles, um, I guess if 2 angles have the same intercepted arc, then they are congruent. Okay, they are congruent. Okay, so we have figured out that both of these angles face or intersect arc TU. So therefore, those 2 angles are going to be congruent. So all we have to do is write our equation. So let's bring this out just a bit and let you know that angle angle S is congruent to angle V. So we'll write that here. So angle S is congruent or equal to, I should say, to angle V. So we're going to set this up. It's going to be 3x equals x plus 16. And so now we're just going to solve for x. So of course, that's going to be minus x on both sides. So it's going to be 2x equals 16. And then divide both sides by 2 to get x by itself, and you're going to get x equals 8. So the value of x is 8. But the question, of course, was to find the measurement of angle S. So to find the measurement of angle S, all we have to do is replace the x in angle S with 8. So basically, angle S was 3x. So basically, it was 3x. So that means it's going to be 3 times 8. So 3 times 8 is 24. So therefore, the value or the measurement of angle S would be 24 degrees. Okay? So again, 2 angles have the same intercepted arc. 2 angles that face the same arc are going to be congruent. Okay? All right, example number 3. And this question is, what is the value of x in this situation? So what we have here is we have a circle here where we have a triangle inside of it. And we have 2 angles given here, F and H, but nothing's here for G. And I wonder why that is. Well, let me share something with you. Basically, if you look at angle G, if I can highlight this, angle G is right here and here. And if you notice, the arc that it's facing, so the arc that it's facing is this arc here, F to H, this way. And could you make a prediction on how many degrees that arc is? Well, you should. That arc is half of that circle. Therefore, it's a semicircle. And therefore, the arc for that is 180 degrees. So if this arc is 180 degrees, remember angle G is an inscribed angle. So angle G, if it's an inscribed angle, remember the inscribed angle is half of what the arc that is intercepting. So that means that angle G in this situation is just going to be half of whatever the arc FH is in this case. And that's just 1/2 times 180. So therefore, 1/2 of 180 is 90 degrees. So therefore, angle G is a right angle. Okay, angle G is a right angle. So therefore, this is a right triangle that we're dealing with. And so these two angles here, angles F and H, are both are the acute angles of that right triangle. So if you remember from dealing with triangles that we've dealt with so much in this class, know that these two angles here, 7x plus 2 and 17x minus 8, are going to add up to 90 degrees because they are the acute angles of a right triangle. So that's how we're going to find the value of x. So let's go ahead and do that at this time. So to find that, what we're going to do is we're going to set up a problem here. We're going to say that angle F plus angle H, the measurements of those, equal 90 degrees. So we're just going to replace the values. So we're going to have 7x plus 2 for F. We're going to have 17x minus 8 for H. And we're going to set that equal to 90 degrees. Okay? And so now we're just going to combine like terms. So we have 7x and 17x. So that's going to be 24x. And then we have a positive 2 and a minus 8. That's going to be a minus 6. So we have, so that's what we have. So 24x minus 6. And then that's going to equal to 90 degrees. Then what we'll do is we're going to add 6 to both sides. So we'll add the 6 on each side. And we're going to have 24x equals 96. Okay. And then we will need to divide both sides by 24 to get x by itself. And that's going to be x equals, and then just do 96 divided by 24 in the calculator if you're not sure. But you should get out that x is equal to 4. So the value of x is equal to 4. And for my question, that's what I want you to find. I want you to find the value of x. So the value of x is 4. But of course, if I wanted you to, which I'm actually going to go ahead and do at this time, you can replace the x in both of these angles, F and H, to determine how many degrees each of those angles are. And so let's just show you that real quick. To find the measurement angle F, of course, all you'll do is you would do 7. It was 7x plus 2. So basically, it's just 7 times 4 plus 2. So 7 times 4 is 28 plus 2, and that's going to equal to 30 degrees. So that angle F is 30 degrees. And then, of course, you could also do the same for angle H. So angle H is going to be 17x minus 8. So therefore, it's going to be 17 times 4 minus 8. So we have 17 times 4 is 68 minus 8 is going to be 60 degrees. So therefore, the value of angle H, we don't need to box it in, but the value of H would be 60 degrees. Okay? So again, if you have a right triangle, basically that's inscribed in the circle, okay, it's inscribed. Remember, inscribed means you're going in the circle, okay? So if it's inscribed, then that's what happens. It's a right triangle. That's how you can inscribe it. And so therefore, the two angles that are remaining, of course, will have to add up to 90 degrees, okay? All right, and now we have example number 4. And here it says that quadrilateral WXYZ is inscribed in circle V. So we know we have circle V, and they want you to find the measurements of angles X and Y, okay? So in this particular picture, they've already given you angle Z, which is 60 degrees, and they've given you angle W, which is 95 degrees, okay? So go ahead and make sure you have that drawn. I'll give you just a moment, and then we'll start doing it, okay? All right, and so now here's a rule that we will learn based on this particular situation. Anytime that you have a quadrilateral inside of a circle, okay? Anytime you have a quadrilateral inside of a circle, what that basically means is that you're going to take the angles here, which in this case is Z at 60 degrees, and notice that Z and angles Z and X are opposite each other. Okay, when angles are opposite each other in an inscribed quadrilateral, like it is here, the angles that are opposite each other are supplementary. Okay, and what does supplementary mean again? It adds up to 180. So let me go ahead and make sure you write that rule, that if you have an inscribed angle, so for or inscribed quadrilateral, for an inscribed quadrilateral, okay, so for an inscribed quadrilateral, okay, the angles or the opposite angles are supplementary. Okay, they are supplementary. And remember, supplementary, supplementary just means, okay, means, remember, supplementary means adds up to 180 degrees. Okay, all right. So just keep that in mind. So that's all we have to do to help us answer this question. So now, so all we gotta do is solve the problem. So let's start with, like I said, we'll start with angle Z since I mentioned that one first. So that means the first equation is going to be the measurement of angle Z plus, and then its opposite, angle X. So the measurement of angle Z plus the measurement of angle X is equal to 180. Okay, so we know that Z is 60 degrees, so it'll be 60 plus the measurement of angle X equals 180. So I'm going to subtract 60 on each side, and I'm going to get that the measurement of angle X is equal to 180 minus 60, or 120 degrees. So we have found the value of angle X. Okay, we will do the same thing for helping us find angle Y, because angle Y is opposite W. So we'll do the same thing. We'll just do angle W plus the measurement of Y is equal to 180. So angle W is 95 degrees plus angle Y, which we do not know, equals 180. And then you're going to subtract 95 on each side. And so 180 minus 95 is going to be 85. So therefore, the measurement of angle Y is going to be 85 degrees. And so therefore, we have found the measurement of both the angles, angles X and angle Y. And remember, the rule is that if it's an inscribed quadrilateral, that means that the two opposite angles, the two pairs of opposite angles are supplementary. Okay? All right. So hopefully this will help you with any problems that you might have for this particular section. So thank you for watching this particular video, and I look forward to seeing your notes that you have copied for this, and of course your work for any problems that you do for this. Okay. So thank you, and have a good one, and see you on the next video.